You're a realtor. Imagine your buyers call a number, describe their dream home, and instantly get matched with available properties, and even have a showing scheduled all without a human picking up the phone. This is completely possible today with AI, and that is what we have built. And here is a demo.
Thank you for calling Joy and Grace Realty. How may I help you today?
Hi, my name is Jerry. I'm looking to buy a single family.
Nice to meet you, Jerry. May I have your phone number so I can follow up with you?
Sure.
Thank you. Just to confirm, your phone number is that correct?
Yeah, that is correct.
Great. Are you looking for a specific location for your new single-family home?
I'm looking in Chicago.
Perfect. How much space are you looking for in square feet?
I'm looking for a 3-bed, 2-bath, and my budget is $500,000 with a square footage of 4,000.
Thank you for that information. Just to confirm, you're looking for a single-family home in Chicago with 3 bedrooms, 2 bathrooms, a budget of $500,000, and about 4,000 square feet. What features must this property have, and what would be nice to have but aren't essential?
Sure. Great schools would be must have, and nearby restaurants would be nice to have.
All right, Jerry, I think I have a really good understanding of what you're looking for. Just one last quick review.
Sure.
You're interested in a single-family home in Chicago with 3 bedrooms, 2 bathrooms, about 4,000 square feet, budget of $500,000. Must have access to grade schools, and it would be nice to have nearby restaurants. Does that sound right?
Yeah, that sounds correct. Yes.
Found a couple of great options for you, Jerry. First, there's a beautiful single-family home located at 81196 Brewer Forest in Wicker Park. It's priced at $529,448, featuring 3 spacious bedrooms and 5 bathrooms, spread over 4,782 square feet. The home boasts a gorgeous chef kitchen with quartz surfaces, stainless steel appliances, and a lovely private patio, perfect for outdoor relaxation. Would you like to schedule a showing for this property?
Yes. How about Tuesday at 1 p.m.?
It looks like the agent isn't available at 1 p.m. on Tuesday, but there are a few other time slots open. Would you like to schedule the showing for either 9 a.m., 9:30 a.m., or perhaps 2 p.m.?
Actually, you know what? I'll do 2 p.m.
The showing has been successfully scheduled for Tuesday at 2 p.m. for the beautiful home at 81196 Brewer Forest in Wicker Park. If you have any other questions or need further assistance, feel free to reach out. Happy house hunting, Jerry.
Thank you. In this video, I'm going to show you how it all works. We're talking live voice integration, automated appointment scheduling, and real-time SMS confirmation, all stitched together with tools like VAPI, Google Calendar, and Anyden. If you want a voice assistant like this for your business or something completely custom, we can help. Whether it's handling inbound calls, following up with leads, or automating something totally unique, we'll help you figure it out. Book a free consultation call with us using the link in the description below. Back to building this awesome assistant. This is part 3 of our voice agent build. If you missed the first 2 parts, here's a quick recap. In part 1, I walk you through the architecture, the tools I picked, and the reasoning behind the key design decisions. In part 2, we went deeper. We explored Pydantic AI, built our agent with prompt engineering, hooked it up with ChromaDB for semantic search, and tested the core flow with text-based chatbot. Now in part 3, we are bringing it all to life with voice. We're going to integrate with VAPI to handle real-time voice conversations. How we handle tricky daytime handling with LLMs when scheduling appointments. We use Anyden to manage backend automation and hook into Google Calendar to book appointments automatically, and followed by instant appointment confirmations over SMS to the caller. Here's what happens after the agent recommends a property. It offers to schedule a showing. The user responds with a time preference, something like next Tuesday in the afternoon. And this is where it gets interesting. because we are dealing with natural language and time. And if you have worked with LLMs, you know this problem well. LLMs like GPT are frozen in time. If I pass next Tuesday into a model like GPT-4, it might interpret that as a Tuesday in 2023 or someday in the past, which is clearly not what we want. So we don't let the LLM handle the date time part. Instead, the agent passes the raw text, something like next Tuesday at 2 p.m., to a tool. That is our code. And that tool is responsible for real parsing and normalization of that input. The tool we use is implemented in getAgentAvailability.py. The agent will automatically call this tool when it needs to find out when the realtor is available. We'll walk through the code so you can see exactly how we convert vague human-friendly date-time expressions into proper date-time objects, and how we compute available slot based on the realtor schedule. This is one of those places where tooling, prompt design, and backend logic all have to work together cleanly. And it's what makes the assistant feel smart and usable in real-world conversations. Let's dive into the code. Right, let's go line by line through the Get Agent Availability tool. It's defined under SRC Agent Tools folder. This function is called by the agent when the user expresses interest in scheduling a showing. Its job is to take in user preferences like next Tuesday afternoon, parse it into a usable date time, find available appointment slots using the realtor schedule, return those options in a format the LLM can speak back naturally. Let's walk through the code now. We register this function as a tool using the realtorAgent.tool decorator that allows the agent to call it when needed. It takes 3 parameters. The context parameter gives us access to the dependencies like the webhook URL, the scheduling config, and the other agent dependencies. Profile contains the user profile, mainly the preferences like name, location, budget, etc. Datetime preference is the raw input from the user, like next Tuesday at 2 p.m. First, we normalize the user profile just to ensure it is in a clean and expected format. We covered normalized user profile in detail in part 2 of the series. Next, we extract the agent's time zone and the innate webhook URL from the context. We also convert the time zone setting into a time zone object which we'll need for all datetime operations. If the user gave a datetime preference, we first clean it up. We remove words like next, this, or coming using regex because the dateparser library that we use can sometimes get tripped up by those in ambiguous ways. Speaking of dateparser library, this is the library that we use to convert spoken phrases like next Tuesday to the actual date time. When we capture the current time in the agent's time zone, which we will use as a reference for parsing. When we actually parse the user's input using the dateparser library, the key settings here are preferred dates from is set to future, so if someone says Tuesday, it picks the next Tuesday, not a past one. We also use relative base to anchor the parsing to the agent's current time, not the system default or UTC. We also set the relative base to now, which is the current date time. The output is a datetime object or none if parsing fails. Here is a little detail that is easy to miss. If the parse time is not exactly midnight, we subtract 2 hours to add a buffer between this and any existing appointments. The idea is to avoid scheduling something too close to another showing, giving the realtor some breathing room. And this buffer time is entirely configurable. If parsing failed entirely, say the input was too vague, we fall back to a safe default. That is tomorrow at midnight in the agent's local time zone. This ensures we always return something instead of erroring out. Now that we have a valid date time, we pass it into compute available slots function, along with schedule config and the innate hook. This function handles the logic of checking the realtor's availability and finding the open time slots. We'll walk through that function shortly. Once we get the raw list of available slots, we format them into a friendly format that the LLM can interpret and read out loud nicely. For example, the agent can respond, the realtor is free Tuesday at 10 a.m., 1 p.m., or 4:30 p.m. And finally, we return the formatted list of time slots back to the agent. So in summary, this is a function that is doing a lot of heavy lifting when it comes to date time. It gracefully handles fuzzy natural language input from the user, parses and cleans the datetime preference reliably, applies logic to avoid back-to-back appointments, and fall back to a default if needed, and then fetches and formats available time slots based on the realtor's calendar. All of that runs automatically when the user says something like, I would like to schedule a showing next Tuesday afternoon. This is what makes the assistant feel smart and natural, like it truly understands and responds to what the user meant, not just what they said literally. Now we have the datetime preference from the caller for scheduling the appointment. Now we need to know the realtor schedule and suggest available slots back to the caller. We'll look at how we compute those available time slots by talking to N8N and Google Calendar. To understand all this, we need to look at the workflow in N8N. I'm running N8N locally. If you're curious how to set that up yourself, I have a separate video on that. I'll drop the link in the description. Now, the workflow you're looking at lives in the same Git repo as our code. It's under the N8N folder, and the workflow name is realestateagent.json. I'll link to that in the description if you want to take a look or import it directly into your own N8N setup. Here's how the workflow works. It is triggered via a webhook, specifically by a HTTP post request that our agent sends. So anytime the user wants to check availability or schedule an appointment, the agent sends a post payload to this webhook. From there, the flow splits into two branches, and which path it takes depends on a mode parameter in the JSON payload. We have defined two modes. Get busy slots. This one queries Google Calendar with a given date. Google returns the agent's busy slots for that day. The next branch is schedule appointment. This is for booking. The payload includes the confirmed appointment time and property details. This branch adds an event into a Google Calendar and then sends a confirmation SMS message to the user using Twilio. It's all no code in N8N, but under the hood, this workflow is a crucial bridge between our LLM agent and the real-world scheduling logic. To make this workflow possible, you need to integrate with Google Calendar and Twilio. First, let's see how to authenticate with a Google Calendar account. This is one of those behind-the-scenes setup that you will only need to do once, but it is essential. Without this, your agent can check availability or book appointments on your behalf. It is a little tricky to set up since we run N8N locally, but I'll walk you through everything I had to configure step by step. First, we have to define our app in Google Admin Console, which is console.cloud.google.com. If you're finding it hard to get to this screen, just search Google Auth Platform in the search bar and you'll get here. I created a new project in Google Cloud Console. In my case, I named it AI in Real World. And under OAuth branding, I filled in basic app information. You need to provide a name of the app and a support email. Google will show this in the OAuth consent screen later. Under the same branding tab, there is a section called Authorized Domains. This is super important because if your domain isn't listed here, Google will block your OAuth request. Here's the tricky part. My N8N instance is running locally, but Google requires a public URL. So I used ngrok to tunnel my local N8N server to the internet and registered those dynamic URLs here as authorized domains. Get a public URL for your local N8N, download ngrok from the ngrok site, and run ngrok with the command ngrok space http space 5678. This will give a public URL, and the public URL will redirect to your app running locally in HTTP port 5678. This is the port our N8N is running on locally. Yes, it's a bit messy, and ngrok URLs can change, but it works for initial testing, and you'd have to do this only once. The URL that you see ending in ngrok-free.app is the public URL. Add this URL to the authorized domains. Also, take a note of this URL as we'll need this again in a second. Next, in the audience tab, you'll need to add at least one test user to use your app while it's in testing mode. For me, that's just my Gmail for now. Under the clients tab, I created a new OAuth 2.0 client ID of type web application. I named it AIRW, Real Estate Agent. When you open the client, there are two critical pieces to set. Authorized JavaScript origins, not used in this case, so I left it blank. Authorized redirect URLs. This is where Google will send the OAuth callback. Since we are using ngrok, provide the ngrok URL here and make sure it ends with REST OAuth to credential callback, just like you see here. When we authorize in N8N, Google will redirect to the URL, so it will work when we authenticate. You can also find your app's client ID and secret here. Now, under data access, I've granted access to just what I need. Auth calendar free busy. This allows my agent to view the calendar, check for busy slots, and schedule new events. Here is the final piece of the puzzle, and this one is easy to forget. When running n8n locally inside Docker, it needs to know what public webhook URL to expose. So I had to set the webhook URL in my docker compose.yaml file. And this URL is the same URL that you got from ngrok. Under environment, add another property, webhook_URL, and provide the ngrok URL. After making that change, you need to issue docker compose force create. And here is the command. That ensures n8n picks up the new public webhook domain. Once the Google Calendar is authenticated, you can actually comment this line out if you're going back to local only use. Again, this is a one-time setup for OAuth. Once you have authorized n8n with Google, you're done. So to recap, set up branding, test users, and OAuth clients in Google Cloud. Use the ngrok to expose your local n8n. Register all URLs, both as authorized domains and redirect URIs. Set webhook URL in Docker. Authenticate Google Calendar once, and you're ready to automate bookings. Once you're done with the setup in Google Cloud Console, click Create New Credential and use the email that you provided under Testing Users to complete the authentication. Once the authentication is complete, you can pick the calendar you want to work with. Let me walk through what it looks like when a user, or in this case, you as a developer, authenticates with Google Calendar through n8n. This is a one-time authorization step that connects your Google account to the calendar node in the workflow. It's what lets the AI agent check your availability and book showings on your calendar. First, you will see the familiar Google sign-in screen asking you to choose an account. You will want to pick the Google account that owns or manages the calendar you want to use. So in my case, I'm using my personal Gmail. The screen you will see is hosted by Google, and it tells you that you're signing into an app running at your public ngrok URL. That's expected. Click your account to continue. Because you're still in testing mode and you haven't submitted this app for Google verification, you'll see a message, Google hasn't verified this app. That's totally fine. You can click continue because you are the developer and you know exactly what the app is doing. You won't see this once the app is published or verified. Next, you'll be asked what permissions the app should have. You want to check both boxes, view and edit events on all your calendars. See, edit, share, and permanently delete all calendars you can access. That's the setting you want to select. I know the second one sounds crazy, but this is required for the app to fully manage events, especially if we want to delete or update booking later. For testing, I recommend you create a dedicated calendar, which you can then select in n8n. You'll also see the ngrok URL again and a note that this app does not have a visible privacy policy or terms yet. That's expected in development. Click continue to confirm access. If everything worked, you'll land on a screen from n8n that says connection successful. At this point, your n8n instance now have a valid token and can access your Google Calendar. The window will auto-close in a few seconds, and your Google Calendar node in the workflow is now fully authenticated and ready to go. Now let's talk about how we send SMS or WhatsApp confirmations. We're using Twilio for this. If you have never used Twilio before, don't worry, it's super easy to get started. Just head over to twilio.com and create a free account. Once you're signed up, Twilio will assign you a trial phone number. This phone number is what we'll use to send outbound SMS or WhatsApp messages to our users. After creating your account, go to Twilio console dashboard. From there, grab account set and auth token. You will also find the private phone number that was assigned to you right there. These three values, SID, token, and phone number, are what we plug into n8n so workflow can send messages. Just a heads up, with the free Twilio trial, there are some restrictions. You can send unlimited messages, and Twilio only lets you message verified numbers. That means before you can test it with a real phone number, you need to verify that number inside Twilio console. This is totally fine for development and testing. But once you go live with a real customer-facing app, you will want to upgrade to a paid plan, which is very affordable and removes these restrictions. Now we have set up Google Calendar and Twilio, let's now walk through the n8n workflow that powers our backend automation, specifically handling calendar scheduling and SMS confirmations. This workflow is triggered by our voice agent whenever a user gives a date preference or confirms a showing. Let's go step by step through how the workflow works. We start with a webhook node. This listens for HTTP post requests at a path called real estate agent. This is the entry point for our logic. The agent calls this webhook and sends a payload with a field called mode. This tells us what the user is trying to do. There are two modes. Get busy slots used to fetch block times from Google Calendar. Schedule appointment used to book the appointment and send a confirmation. Right after the webhook, we hit a switch node. This node inspects the mode field in the request body and routes the execution down one of the two branches. It checks body.mode get busy slots or body.mode schedule appointment. Each branch triggers a different calendar operation. Branch 1 is get busy slots. If the mode is get busy slots, we move to a Google Calendar node configured to list free busy times. It uses the start and end times from the incoming payload and calls Google Calendar's free busy API. Once we have the busy slots, we immediately pass them to a respond to webhook node, which returns the response to the caller, in our case, the AI agent. That's it. This path just fetches what times are unavailable. With the list of busy slots, our code compute the available slots for the realtor. Branch 2 is schedule appointment. Now the more interesting path, booking an appointment. If the mode is schedule appointment, we route to another Google Calendar, but this time it's configured to create an event. It takes start time and end time. A title like showing for Jerry with a description which includes full property and user info. All of this comes straight from the JSON payload sent by the agent. Once the calendar is created, we pass it to an if node that checks status confirmed. This is Google Calendar's response, and we use it to verify the booking was successful. If the status is confirmed, we call a Twilio node to send an SMS confirmation to the buyer. The SMS includes the description text we used in the calendar event, a follow-up message like, if you'd like to make changes to the appointment, text directly to the realtor at a given phone number. The phone number we use to send SMS comes from the webhook payload. Finally, we finish by responding to the webhook with either a success message or a fallback. If a calendar status wasn't confirmed, we skip Twilio and respond directly back to the agent. So to sum it up, this n8n workflow listens for voice agent's requests, routes the logic based on mode, handles calendar availability checks, book a calendar appointment if needed, and sends out SMS confirmation to the caller through Twilio. This lets us keep the agent lightweight. No calendar logic baked into the agent's code. All scheduling logic lives in this n8n workflow. And because this whole thing is webhook driven, it is easy to test, monitor, and update without redeploying the backend. Now that we know how n8n workflow is configured, let's jump back into code and see how our code calls this workflow to fetch realtor schedule to compute available slots. We've looked at how get agent availability parses the user's date time preference, and once we have a valid date time, we call into this function, compute available slots. This is where we calculate open appointment times for the realtor using their working hours, buffer times, and current Google Calendar events fetched via n8n. Let's go through the code line by line. This function is defined in times util Python script under the utils folder, and it takes three inputs. The date time we parse from the user input, a config object describing the agent's working hours and buffer settings, and the webhook URL for calling into n8n to fetch the agent's current schedule. We extract all the key scheduling parameters, start and end of the realtor's workday, duration of each appointment slot, a buffer we want between appointments, and the time zone which we will use for localization. We convert the realtor's time zone string into a time zone object. Then we grab just the date part from the parsed date time. So if the user said Tuesday at 2 p.m., we pull just the Tuesday portion, we'll loop through the day to find open slots. This is where we ask n8n to call Google Calendar and tell us what times the agent is already booked for. We'll use this list to avoid scheduling conflicts. As you can see, we are calling a function here, fetch busy slots from n8n. Let's go into this function. This function is defined in appointments util Python script under the utils folder. This function makes a call to n8n with this payload. Pay close attention to the mode parameter in the payload. We're asking for get busy slots. This will make the n8n to take this route, reaching to the Google Calendar, asking for all the scheduled appointments from realtor's calendar for a given date. Once we have the scheduled or busy slots, we add all the busy slots into an array. We'll send it back to compute available slots. Once we have the realtor's busy slots, calculating available slots is super simple. We calculate the actual date time range that represents the agent's workday on that day. Notice how we subtract appointment duration from the end time This is to ensure the last slot does not run beyond working hours. We start at the beginning of the workday and move in 30-minute increments. For each potential slot, we calculate a proposed end time. And again, all these parameters are configurable. We loop through every existing appointment on the calendar and check whether the proposed slot overlaps before or after those times, even accounting for the buffer window we defined earlier, just to make sure we are not scheduling back-to-back appointments. If there is a conflict, we skip the slot. If no conflict is found, we convert the date time to ISO format and add it to the list of available slots. Then we move forward by 30 minutes and repeat the same process again to find the next available slot. Finally, we return the list of open time slots as ISO formatted strings. These raw ISO strings are great for API, but we need to make them human readable for the LLM. That brings us to the next function. This utility function takes the list of ISO strings and turns them into something that our agent can leverage to create a friendly and voice-ready response when offering available slots. It also adds a time context, so the assistant can say something like, "We also add the current time context to the response." We loop through every available time and convert it from ISO into a natural sounding string, something like Monday, June 3rd at 2 p.m. Finally, we package everything into a dictionary, return it as a JSON string, clean, readable, and ready for LLM to deliver it to the user. So between the compute available slots and the format slots for LLM, we have now handled working hours, time zone awareness, calendar integration via Inaden, buffering rules, and friendly output formatting for the LLM. All of this happens automatically once the user says something like, "I'm free next Tuesday afternoon. Can we schedule it then?" This is one of those places where real-time logic, calendar APIs, and LLMs all come together, and when it works, it feels magical. We are now ready to see how the agent books the appointment and sends out SMS confirmation via Twilio. Our agent now offers the available slots. Our caller picks a time and says, "Yes, Monday at 11 a.m. works for me. Let's schedule the showing." At this point, our agent does not need any more clarification. It already knows the property being discussed, the caller's preferences, and the selected time. So now it just needs to book the appointment. And that's exactly what happens automatically behind the scenes using the tool Schedule Appointment. Let's walk through the code. The Schedule Appointment tool is defined in the Python script file Schedule Appointment under the folder src agent tools. We register this function as a tool the agent can call using the realtor underscore agent, which is the name of our agent, .tool decorator. This function receives the context, which includes things like the webhook URLs and other configurations via the agent dependencies, then the user profile and the selected property, and finally the user's confirmed time passed as raw string like Tuesday at 3 p.m. We clean up and normalize the user profile just like we did before, ensuring we are working with structured, predictable data. We then grab the agent's time zone and get the current localized time. This will help us parse the user string into a real date time. We use the dateparser library again to handle natural language input phrases like this Saturday or tomorrow morning to an actual date time. If the date time parsing fails, we gracefully return a polite error message and let the user or the caller try again. We make sure the start date time is time zone aware. Then we calculate the end time as exactly 1 hour later. We assume showings last about an hour, but this is configurable as needed. And here is where the magic happens again. We send everything over to our Inaden webhook to actually schedule the event and trigger downstream actions like SMS confirmation. Let's look at what happens inside send appointment to Inaden. This function is defined in appointments util file under the utils folder. This function takes the user profile, selected property, start and end times, and pushes them into our Inaden webhook. We create a clean, readable title and body that will show up on the Google Calendar invite. It includes the property info, username, phone number, and appointment time. Remember, this is our realtor's calendar, so the appointment clearly gives all the needed information for the realtor. Next, our payload. Notice the mode field, it tells Inaden which branch of the workflow to execute. In this case, we are signaling that this request is for scheduling. The payload contains the listing ID, an appointment time, the calendar event title and description, user contact info, specifically name and phone number. Since the mode is schedule appointment, the Inaden workflow takes this path. Because as you can see, this branch is for schedule appointment. It first schedules an appointment, And once this is successful, we use the Twilio node to send an SMS to the caller. If anything fails in N8N, maybe if the webhook is down or the Google Calendar throws an error, we return a polite fallback message and log the exception. We're all set to test end to end. In part 2, we stopped right when the agent made the recommendations. Now, let's test booking a showing for a property. We'll run 2 tests. In test 1, we'll ask for an open slot. Let's say 11 a.m. on Tuesday, and we'll confirm that the appointment is scheduled. In test 2, we'll ask for the same slot again, 11 a.m. on Tuesday, and we'll see how the agent handles the conflict. This will test whether the get agent availability logic properly blocks off already used time slots. Let's go ahead and run both the tests. We're going to run the same chat Python script. Here's my calendar for Tuesday, June 10th. It's pretty empty. All right, let's go ahead and give in our preferences. Okay, it's asking for my name. I'm going to give my name. All right. Now it's asking for the phone number. So it's confirming the phone number. And it's asking if I want to buy or rent. I'm going to say buy. I'm going to say Chicago for the location. Single family is my choice. I'm going to say 3,000 square feet. Budget would be, let's say, $350K. 3 beds and 2 baths. Okay. Great schools as usual for the must-have. A big backyard would be a good, nice, right? So it's confirming all the preferences that we have entered so far. So let's go ahead and confirm. Now our agent is recommending a property. And not only that, it is asking if we want to schedule a showing for this property. I'm going to say yes. And I'm going to say, how about Tuesday at 11 a.m.? I showed you before, my calendar is pretty empty. And the agent rightly says Tuesday at 11 a.m. works perfectly. I can confirm that time for your showing. Would you like me to go ahead and schedule it? I'm going to say yes. And there you go. We now have the appointment in the Google Calendar. And I also got a text message in my phone. Okay. Test 1 ran perfectly. Let's move on to the second test. In the second test, we'll ask for the same slot again, 11 a.m. on Tuesday, and we'll see how the agent handles the conflict. Let's enter all our preferences again. We have a recommendation now, and our agent is asking if we would like to schedule a showing. I'm going to say yes, and I'm going to ask for the same time slot as we did with test 1, which is 11 a.m. on a Tuesday. How about 11 a.m. Tuesday? Okay, our agent looked at the calendar. It saw 11 a.m. Tuesday isn't available, and it is giving us some alternative slots. It clearly says it looks like the agent is available for showings on Tuesday, but unfortunately, 11 a.m. isn't an available slot. Here are a couple of alternatives. So it's giving us 9 a.m. and 12:30 p.m. as alternatives. And you should also notice here that we didn't give a date specifically, right? We just said 11 a.m. on a Tuesday. Our agent correctly inferred Tuesday to be a future date and picked up June 10th as the date. I'm recording this on June 7th, so June 10th is the next Tuesday, which we would expect to see. All right. Now I'm going to say 12:30 works for me. Let's go back to our calendar. And there we have it. We have our appointment scheduled at 12:30 as we requested. Another thing to note, the agent did not offer noon as an appointment because in the agent schedule config, we have instructed our agent to keep a 30-minute buffer between the two appointments. So everything from the appointment scheduling and integrations with Google Calendar and Twilio works perfectly fine, which means we have a solid end-to-end automation. All right. So far, we have walked through the code. We have seen how availability is calculated, how appointments get scheduled, and how we trigger Twilio SMS and schedule an appointment with Google Calendar via n8n. We've also tested the end-to-end flow with a text chatbot. Now let's bring everything together. This is where voice meets the backend. Let's take a look at how we wired this up inside VAPI. What you're seeing here is the assistant configuration inside VAPI. I've named it Real Estate Agent, and it is configured to use custom LLM, not one of the default models VAPI offers. And that's important because all the logic, everything we built using Pydantic AI lives in our backend. The agent logic, the tools like get agent availability and schedule appointment, the rack setup, the voice-friendly prompting, all that is happening outside of VAPI. VAPI is purely the voice interface. It listens to the caller's voice, sends the transcript to our LLM endpoint, receives the response, and speaks it back to the caller. So right here, under the Model tab, we configure our custom LLM URL. We use ngrok while testing, but in production, this would point to your deployed fast API backend. The first message mode is set to Assistant Speaks First, and I wrote a friendly little greeting. Thank you for calling Joy and Grace Realty. How may I help you? For the system prompt, I just said, read out the responses from the model in a friendly manner. That's it. Because our full system prompt comes from our Pydantic AI agent from our backend. Now let's talk about voice. Under the voice tab in VAPI, I've chosen 11 Labs as the provider. And I'm using the voice named Sarah with the model 11 Turbo V25. I played around with few options here. VAPI's default LLM voice provider had issues on longer messages. The output would sound weirdly stretched or robotic. Sometimes it would drag the end of the words like it was losing steam mid-sentence. In contrast, 11 Labs gave me a clean, natural-sounding voice output. And for something like a real estate voice agent, that matters. A warm and conversational tone is key when you're helping buyers schedule showings. VAPI also gives you a free phone number to test inbound calls. You can see here I have linked this phone number directly to my real estate agent assistant. So whenever someone dials in that phone number, the assistant kicks in and routes the transcript to our backend. A quick note about free phone numbers from VAPI. There is a limit on inbound and outbound calls with free numbers, so keep that in mind. Now, there are some advanced voice settings like start speaking plan and stop speaking plan, and these are important settings. I'll cover those in a separate video because they need a bit of nuance. And these settings are crucial, especially when handling interruptions or thinking time between the user and the agent. And again, the logic still lives with us. VAPI is just the messenger. It is now time to look at the code which is called by VAPI at runtime. Let's now dive deep into the Python code that powers our voice interaction through VAPI. The script we're looking at is called voice_VAPI, and it sits under the src directory in our project. This script is the core of our voice agent backend. It is what VAPI talks to every time someone calls the real estate number. VAPI sends a transcript of what the caller said, and this script responds with what the agent should say next. Let's break it down top to bottom. We'll start off with some standard and third-party imports. I will just talk about the key ones. Fast API powers our web framework. Lightweight, async, and perfect for building an API that VAPI can call into. Streaming response is used to stream the agent's response back to VAPI in real time. We use Logfire to add observability for our AI agents. As you know by now, Pydantic AI is the framework we have used to build our conversational agent. Usage from Pydantic AI tracks token usage and lets us calculate the LLM cost later. Next, we load environment variables and initialize a few key pieces. These come from your .env file. They let us configure the ChromaDB path, webhook for n8n, time zone, and the port to run the fast API server on. When we create the fast API, and an in-memory dictionary used to store state per session, VAPI assigns a unique call ID to every call, and we use that to track each caller's session. The session also has message history and token usage. We then create an agent schedule config and bundle up all our dependencies. This object will be passed into the agent every time it runs. So it has everything it needs to, like where to query listings from, what webhook to call, etc. Now for the main event. This is the endpoint that VAPI hits. It receives a transcript of what the caller said, and we respond with what the agent should say next. We pull out the session ID and user message, then we check if we already have session state for this call. If not, we create a fresh one. Then we run the agent, and here's what is happening. The agent sees the current message. It has access to the past messages via message history. It can call tools like recommend properties or schedule appointment. It records usage metrics. This is one of my favorite touches. We use the token usage from Pydantic AI usage and pass it to compute cost. This tells us exactly what that interaction cost in terms of OpenAI tokens. Very handy for estimating burn rate if you're deploying this at scale. And finally, we format the response in a format that VAPI expects. And then we stream it back using streaming response. At the bottom, we start the fast API app. We run it with UVCon, expose it on the configured port, and enable live reload for local dev. So to recap, this script is the bridge between voice and logic. VAPI sends audio, we get a transcript. We run the agent, we stream the response back. We inject context, maintain session history, call tools, and even calculate cost. It is clean, efficient, and production friendly. Now we have seen how every functionality is implemented end to end, and we have walked through the code as well. It's now time to do a final demo and see everything in action end to end. As the assistant with VAPI, first run the voice VAPI Python script. Once you have that running, start ngrok by issuing ngrok http 8000. This will give you a public URL. A request to this public URL will be redirected to your assistant, which is running on port 8000. Pretty handy, right? Next, make sure to take the public URL from ngrok and paste it in the custom LLM URL in VAPI, like you see on the screen. That is it. Now we are ready to make the call. From my phone, I will now call the VAPI number, which is tied to our agent. Let's call.
Thank you for calling Joy and Grace Realty. How may I help you today?
Hi, my name is Jerry. I'm looking to buy a single family.
Nice to meet you, Jerry. May I have your phone number so I can follow up with you?
Sure.
Thank you. Just to confirm, your phone number is that correct?
Yeah, that is correct.
Great. Are you looking for a specific location for your new single-family home?
I'm looking in Chicago.
Perfect. How much space are you looking for in square feet?
I'm looking for a 3-bed, 2-bath, and my budget is $500,000 with a square footage of 4,000.
Thank you for that information. Just to confirm, you're looking for a single-family home in Chicago with 3 bedrooms, 2 bathrooms, a budget of $500,000, and about 4,000 square feet. What features must this property have, and what would be nice to have but aren't essential?
Sure. Great schools would be must have, and nearby restaurants would be nice to have.
All right, Jerry, I think I have a really good understanding of what you're looking for. Just one last quick review.
Sure.
You're interested in a single-family home in Chicago with 3 bedrooms, 2 bathrooms, about 4,000 square feet, budget of $500,000. Must have access to grade schools. And it would be nice to have nearby restaurants. Does that sound right?
Yeah, that sounds correct. Yes.
Found a couple of great options for you, Jerry. First, there's a beautiful single-family home located at 81196 Brewer Forest in Wicker Park. It's priced at $529,448, featuring 3 spacious bedrooms and 5 bathrooms, spread over 4,782 square feet. The home boasts a gorgeous step kitchen with quartz surfaces, stainless steel appliances, and a lovely private patio, perfect for outdoor relaxation. Would you like to schedule a showing for this property?
Yes. How about Tuesday at 1 p.m.?
It looks like the agent isn't available at 1 p.m. on Tuesday, but there are a few other time slots open. Would you like to schedule the showing for either 9 a.m., 9:30 a.m., or perhaps 2 p.m.?
Actually, you know what? I'll do 2 p.m.
The showing has been successfully scheduled for Tuesday at 2 p.m. for the beautiful home at 81196 Brewer Forest in Wicker Park. If you have any other questions or need further assistance, feel free to reach out. Happy house hunting, Jerry.
Thank you. Okay, let's talk about the demo we just saw. Honestly, it was flawless. The whole call felt completely natural, fully conversational from start to finish. The voice agent understood what we are saying, asked follow-up questions, and made a recommendation that was actually tailored to the preferences we gave. It wasn't just repeating stuff from a script. It actually got what we wanted. Then we gave it a preferred time for the showing, and this is where things can get tricky. But the agent handled it beautifully. Behind the scenes, it parsed our natural language date, like next Tuesday afternoon, and turned that into a usable date time and called our availability tool. When the time slot isn't available, the agent did not freeze or throw up an error. It simply resolved the scheduling conflict by checking the calendar and offering alternative slots, all while keeping the tone friendly and conversational. And once we agree on a date time, it booked the appointment directly in Google Calendar. No lag, no back and forth, no friction. And then it fired off an SMS confirmation using Twilio just like a real assistant would. All of this, start to finish, happened with zero human involvement. The realtor didn't lift a finger. It's fully automated. Calls come in, the AI does the work, and the agent gets booked. That's the power of tying together voice, AI, calendar, and SMS workflows. And that's exactly what we built here. All right. Before we wrap up, let's quickly talk about the cost of the call. I'm only going to focus on two things here: the LLM cost and the cost of the call in VAPI. We'll leave out the infrastructure stuff for now, just keeping it simple. So let's start with the LLM cost. We are tracking the LLM cost directly in our code. Every time the agent runs, we record how much the prompt costs, how much the completion costs, and then show the total. And we print it right here on the call. For example, the total cost of our last call was 0.004963. So yeah, not bad at all. These micro interactions are really cheap, especially since we are using GPT-4o Mini. Now on the VAPI side, if you want to look at the full breakdown of a call, including cost, you can do that from the VAPI dashboard. Go to your assistant, and on the far right, you will see three little dots. Click on those. And click on Call Logs. Open up the call you're interested in seeing. This will open up the call details. Here, you can see the full transcript of the call, where you can scroll through the entire conversation, see exactly what the agent said and what the caller said. And right there, you'll also see the call cost. And here, you can see the full breakdown of the cost. Our last call costed us 35 cents. So keep in mind, there are a few other costs you may want to factor in. If you're using a paid Twilio number to take these inbound calls, or with international access, that's going to add it to the overall cost. And then there is deployment. If you're hosting this somewhere like Render, that will add to your cost depending on the plan you choose. So if you're planning to deploy these for real users, you need to factor those infrastructure costs as well. But yeah, bottom line, the LLM and the voice interaction costs are very low, especially for the value this thing delivers. And that wraps up our 3-part series on building a fully autonomous real estate voice AI assistant. We started from scratch, collecting user preferences, validating them, and turning them into structured data. Then we built property recommendation engine using semantic search and vector embeddings with ChromaDB. We integrated all that into a conversational flow powered by Pydantic AI, and finally hooked up everything to VAPI for real-time voice. We also integrated our assistant with N8N, powering integrations with Google Calendar for scheduling appointments and Twilio for sending out SMS confirmations. The end result? A voice assistant that talks to users normally, recommends homes based on their preferences, handles scheduling conflicts, book appointments straight to the Google Calendar, and sends an SMS confirmation. All without any human in the loop. That's pretty wild, right? But here's the thing. We are just getting started. In the next series, we are switching gears. We're going to build something way more ambitious. a recruiter voice AI agent that interviews software engineers over the phone, evaluates them, and write up scorecards, all powered by LLMs and with full automation. Think of it as an AI powered technical interviewer that never gets tired, never forgets a question, and always follows up. This one's got a bunch of cool challenges around interview dynamics, structured evaluations, prompt tunings, candidate behaviors. It's honestly a whole other beast. And don't forget about the automation. We are doing an end-to-end automation all the way from a candidate scheduling an interview and our multi-agent workflow conducting the actual interview and evaluating the candidate. So if you've been enjoying this kind of behind-the-scenes real-world AI building, now it's the perfect time to hit subscribe. I've got a ton more project ideas, each one more practical, more useful, and yes, occasionally more chaotic than the last one. If you want this real estate AI voice assistant for your business or want a voice assistant, something completely custom, we can help. Whether it's handling inbound calls, following up with leads, or automating something totally unique, we will help you figure it out. Book a free consultation with us. Link is in the description below. Thank you so much for watching and see you in the next video.